All right, if you want to process a cozy spectrum, first open your data set and remember that each manufacturer has a different directory structure. Agilent will if you run it under automation, will have uh, the specific experiment labeled underneath it. So you'll see proton, nosy, cozy, carbon. So if you wanted to load an Agilent data, you would first load your proton, click the FID there. And if you want to then load the cozy, underneath the cozy, you'll load the FID there also. If you run a Brooker 2D, then underneath Brooker, you'll have numbered folders. And usually the first one is the proton and second carbon, but it depends on how you acquired the data. But all the files, 1D or 2D, will be FID, and then open it. If you have saved your Brooker or Agilent as an MNOVA data set, it will just be a flat file. And so you would click on the file name, open it, and inside that file there could be 1 and 2D, everything that you ran and processed saved together. So I've already opened Cozy set for menthol. I think a really good thing to do is first load your proton, get it phased, get it referenced correctly, and then load your 2D. That way then you won't have less trouble referencing your Cozy. Once you have your Cozy open, you have the zoom and display commands are pretty similar to the 1D. If you happen to have a middle scroll mouse button, you can roll it and it changes the intensity of the 2D. If you hold the mouse over the 1D, then you can change the intensity of the 1D for both sides like that. If you want to expand on a region, click the magnifying glass, expand here, click back to full, and then you can try to look at the processing. Most of the things will be brought from the acquisition parameters, and the auto processing works pretty well. Usually with a Cozy, there's not too much you have to do, but you should make sure your reference is correct. Look at if you happen to have TMS in there, this one is TMS, or if you want to reference to your solvent, expand on that. You want to make sure that the cross peaks on the diagonal line up with the proton that corresponds to it. So each peak has a peak on the diagonal here, and you can expand on the one for the. So here's the cross peak for TMS. An easy way to reference is under analysis, and then click the drop-down menu and graphic reference. Now that way you can get on the 2D display and put your crosshairs right in the center of the cross peak. And then if your 1Ds don't line up with it, you can take the red cursor then and then place it line up and on the top side with the cursor here, and then on the side view here. So this direction here is called F2, and this direction is F1. So that's a convention you should get used to looking at with 2D. Let's just make it wrong to start with. So if you click here, then it actually moved everything, so it's not in alignment anymore. So to re-reference, you click on the cross peak that you want to do, and then go line up in the F2 dimension with that crosshair, and then line up in the F1 dimension with this one. Then click, and then it lines them both up. So that's an easy way to reference if you've referenced your 1D before you started working on your 2D. The next thing you might look at is the apodization. Usually those numbers come in are pretty good from the acquisition files, whether it's Brooker or um, Agilent. But it's good to know what those numbers are in case you ever have to change it. So if you just click apodization, and then you can set the numbers for either F1 or F2. So they can be different, but since this is symmetrically collected data set, they'll probably be pretty similar. The default for the Agilents usually is sine square, and then there's a second sine square that looks a little different here. Sometimes it's a little better, but I can show you what that looks like. If you go to FID preview, then you've got a display of the FID in the F2 dimension and the functions being multiplied by. So it needs to be driving the signal almost to zero at both the start and the finish for a cosy to look correct. So if you turn this off, you can kind of see down here how bad the spectra gets. So if it's on, kind of looks like a cosy normal. You turn it off and you've got streaks in every direction. You go to the other sine square function. It's a little different, and you get a little cleaner spectrum close to the diagonal. You can try the different functions and then just look at the results on the display. As long as you have interactive on, it will show the processing as soon as you click it. For this one, the sine square looks a little better, and you need to adjust it for both directions. So this is in the F2, this is in F1, and have a similar or the very same function in the F1 direction, and then just click OK. So let's go back to the normal view. You've got filter function about right. There's no phasing for cosy, for the gradient cosy is the way we normally collect it. So those icons are off. There's a couple of things that you can make your spectra look better. Cosies work really well. So as long as you have a reasonably concentrated sample and you collect the data somewhat correctly, it'll come out okay. When you need to adjust parameters is when you're trying to look at peaks that are really close, like things that are really close to the diagonal, then all the parameters will start to make more of a difference. Let's take a look at some of the issues. And the first one you see are these streaks that go up and down. That's referred to as T1 noise. There are a couple different ways to get rid of it. The easiest, but not the best, is to symmetrize it. And since the experiment is symmetrical about the diagonal, it goes through and only displays things basically that are the same on both sides of the diagonal. So that eliminates these ridges because it doesn't have a corresponding point on the other side. But it also kind of distorts the way the real peaks look. So if you try it and see how it looks for yours. So that got rid of the ridges, but it sort of makes the cross peaks kind of blocky. And then you start to see things like cross peaks that aren't real. So you're seeing a cross peak in TMS to something in the menthol, which you know is not right. But what it is a ridge here, and then there are ridges that go up and down with these tall peaks. So between tall singlets, you'll usually see what looks like cross peaks, and they're really not. So that one's okay if you want to clean something up quickly, but if you're looking at small couplings, not really the best choice. Let's go back and try some other things. So now we've got the T1 ridges back. Another option is just to reduce T1 noise. And so you can click that and change the cut so it looks, initially doesn't look as good, but if you go back to the normal cut, you can see we've gotten rid of all the ridges that go up and down. And you're really not getting those fake cross peaks that we were seeing with the symmetrization. So that's often a better choice. Another issue comes up with the size of the data that you collected. So when you collect a COSY, you're basically running 128 spectra or 256 spectra. It's like collecting 1Ds over and over. So there'll be, if you collect 128 on the Agilent system, that's about a 5-minute experiment. And this one is collected 128 by 1K. So that's 128 1Ds that are 1K, have 1K resolution. And you can kind of see this, it's kind of low resolution, but if your peaks are have enough space between them, you can usually figure out what you want with just a 5-minute COSY. So this one is a 256, and you can see the difference there in the resolution, especially as you get close to the diagonal and cross peaks that are close. So this is about a 10-minute one. And then you have, this one's about a 20-minute one. So you're really starting to see the difference in the resolution. So the 1K is 1,024 points across F2, and the 128 is how many points are across F1. And so you can kind of see that in the lack of resolution in this direction, because in this direction we have enough resolution to see these two peaks here. In this direction where the resolution is lower, it's just turned to one peak. Now, one of the new things that's come along with the with MNOVA is the option of the covariance. And if you just use the default conditions, it works pretty well. Now, what this does is it looks at the resolution you have in this F2 direction, and it transfers it or can calculate the same resolution in this direction. If you go under more, and we're in the processing menu, just click covariance and covariance here, and just use the default conditions. And you get a pretty good look in nosy or COSY. So, but you also end up with these fake cross peaks like you do in symmetrization. So you have to be aware of that. And also here, this is a little bit of water in the menthol, so you're getting kind of a cross with that shows cross peaks that aren't real. But it's a way to get a 5-minute spectra looking a little more reasonable. You can start to see some peaks along the diagonal here that weren't resolved before. And these peaks now are two separate instead of one blur. But still, really the best data is when you run a full 512. So that's 512 1K spectra. So you've almost got the same resolution in F1 as you do in F2. So that's really the best if you have time. If you don't have time, on the instrument, you can usually press with the 5-minute one as long as your peaks are separated well and your concentration is reasonably good. A few other display options is if you, for some reason, you end up losing your 1Ds, here you can, if you right-click here, and then you get, or on the Mac, it's Control-click, and you can click Show Horizontal Trace, turn them off or on. So if you get a 2D display that's not showing the 1Ds, you can turn them on there. You also have some options under the right-click or Control-click with a Mac, and do Properties. And then you have a number of things you can do. You can change some 1D parameters, and then in the 2D, you can change the colors of the cross peaks and go from, this one has only positive cross peaks, so you won't get the second color. But when we start doing noses, you'll see the two different colors. but we can change it to green, just so you can see it change here. So it changed your cross peaks to a green color. And I think that's about it for cozies. We'll move on now to HSQC.